Hello, my wonderful class. We're now going to be talking about some proportions that lie within similar triangles. So we're going to have some similar triangles that form, which will create proportional parts within the triangle. So basically we're going to be setting up lots and lots and lots and lots of proportions, which the way that we solve a proportion is by cross multiplying. So if you love to cross multiply, this section is your section. Okay, let's get going on our first type of proportionate similar triangle. So the triangle proportionality theorem, or it's also referred to as the side splitter theorem, sounds a little violent. But anyways, if a parallel line to one side of a triangle intersects the other two sides of the triangle, then the line divides these two sides proportionally. So if you guys see here, we have this triangle, and then we have this quite rude parallel line that crosses through it, which how I know this is parallel is because of these little arrows right here. Okay, so if you have a parallel line that's crossing through the triangle and it is parallel to one of the sides, guess what? It will split up the two sides that it intersects into proportional pieces. So if you look over here, this could mean, if it looks like this, it could mean that A over B is proportionate to C over D. So it's kind of like you're going down the two sides of the triangle that the parallel line is sliced in half. Okay, or not necessarily in half, but the parallel line has crossed through. Okay, so you could go down the sides like so. So you could say A over B equals C over D. Or this is the same thing as going across the triangle. And again, this only involves the sides of the triangle that the parallel line is intersected. Okay, so I could also say A over C will equal B over D. Okay, so again, be careful, you guys. This has nothing to do with, if you guys see here, the two bottoms of the triangle, it was not split by a parallel line. They are the parallel lines. Guys, so the two sides of, or the side of the triangle and then the parallel line, the side of the triangle that's parallel to the parallel line, these two parts are not included when we write our proportions. So just be really careful. Only the parts of the triangle that were intersected by the parallel line are the proportionate sides. So again, A over B could equal C over D. You could go down the triangle or you could go across. Okay, so you could say A over C equals B over D. And no matter which way you choose to solve the problem, you'll get the same answer, which is really cool. Okay, so in example 1 and 2, we'll be applying the side splitter theorem or the triangle proportionality theorem. Okay, which I'm going to start example 1 with you right now. So let's see here. All right, let's get going, which, come on thing, keeps freezing on me. Okay. Sorry guys, this thing tends to freeze on me. I think the demon cats get it. But anyways, so we're going to be using the triangle proportionality theorem or the side splitter theorem to solve for all the variables, which if you see here, we have y and z. Now, remember the triangle proportionality theorem can only be applied to the sides of the triangle that the parallel line is intersecting with. Do you guys see how the parallel line is not intersecting with this side of the triangle? That means I cannot include these two parts, z and 23. I'm going to have to solve using something else, okay? But I can use these two pieces and these two pieces to set up a proportion, which is really cool. Guys, and I'm going to show you that no matter which way you choose to set up your problem, you get the same answer, okay? So the first way I'm going to go, you can go like down the sides of the triangle that the parallel line is crossed through. So I could go down this way. Okay, so I'm going to set up my first proportion just like that. I'm going to say 12 over y equals 10 over 6. Okay? The other way that you could set up the problem and you will still get the same answer is if you go across the triangle. So I could also set it up like this. I could say like 12 over 10 will be proportionate to y over 6. So I could also say 12 over 10 equals y over 6. And again, when you guys do this, you always need to start from the same kind of spot in the triangle. Like here I went like from the top of the triangle to the bottom. Then I went from the top of the triangle to the bottom. Okay, here I went from the left side of the triangle to the right side. And then again, I went from the left side to the right side. So it's really important when you set up your proportions that you kind of move in the same direction of your triangle when you set up each fraction or each ratio. Okay, and then from here, let's go ahead and get going, you guys. So before you start solving a proportion, which the way we solve a proportion is by cross multiplying. Before we start cross multiplying, it's always easier if you can reduce down any of your fractions, because the smaller the number, the easier it will be to work with. Okay, so I see here that 10 over 6 can be reduced down. So I'm going to reduce down 10 over 6 real quickly. Okay, so what is a number that will divide into 10 and 6? It would be 2. So I'm going to divide both of these by 2. Okay, so 10 divided by 2 is 5, and 6 divided by 2 is 3. So I'm actually going to be using 5/3 in my ratio. So I'm going to rewrite this. 12 over y equals 5 over 3. And now my numbers will be smaller, which will make my life much easier. Okay, well, let's get going. So when we have a proportion, guess what? We're going to cross multiply. So I hope you like to cross multiply, because we're going to be doing it over and over and over and over and over again. Okay, let's get going. So y times 5 will give me a 5y, and that will equal 12 times 3, which will give me 36. And then from here, I just solve for y, which the 5 and the y are secretly multiplying. So the way I bring my 5 to the other side is by dividing that thing on both sides, which this marker is struggling. Okay, so 5 divided by 5 will cancel and turn to 1. So we're left with y equals, well, 36 over 5 will not reduce down any further. So I'm just going to leave it as 36 over 5. So there you go, you guys. That's it. Okay, now, you don't have to technically do the problem again, but I'm going to show you that if you set it up going the other direction, you will still get 36 over 5. Okay, so I'm going to show you that real quickly. Again, I'm going to see if any of these fractions will reduce down, which 12 over 10 will reduce down. So I'm going to bring that over here. Okay, so 12 and 10 can both be reduced down. I can divide 2 into each of these. So 12 divided by 2 gives me a 6, and 10 divided by 2 is 5. So I'm going to rewrite this using 6 over 5 instead of 12 over 10. All right, and you guys, your minds are about to be blown. You're going to see that you get the same thing. Okay, so I have 6 over 5 equals y over 6. Okay, let's start cross multiplying. So I have 5 times y, which is 5y. And then I have 6 times 6, which is 36. And I just solve for y. Okay, which the 5 and the y are secretly multiplying. So the way I bring my 5 over is by dividing both sides by 5. Which 5 over 5 cancels and turns to 1. And 36 over 5 will also give me 36 over 5. So if you see here, you get the same thing both ways. So whichever way you prefer is the way you can solve. All right, now we also need to find side z. Okay, which, be careful, side z is the parallel line. It is not being intersected by the parallel line. So we got to be really careful. Okay, this will only work if we're using the sides that the parallel line is crossing. The two parallel sides, this theorem does not apply to. Okay, so so we need to think back to our previous section when we kind of look at the two overlapping triangles. Do you guys see this small triangle right here? I'm going to shade in. We have a small triangle, and then we have this big triangle right here. Okay, so if I'm going to use proportions to solve, I need to think of it this way only when I solve for z. I don't have to do this when I'm using one of the sides that the parallel line is divided by, or divided into, or intersected into, I guess, is a better way of saying that. Okay, so, and I'm going to use, technically we know what y is now, so I could replace y with 36 over 5, but fractions are usually more difficult to work with. I know that fractions are our friends, you guys, but if we don't have to use fractions, then that would make our life a little easier. Okay, so I need to use the z 23. So I'm going to start with z in 23. So z comes from the little triangle. So I have z over 23 is one side of the big triangle. So z over 23 will equal. Now I'm going to use these sides of my triangle because, again, I already know the values and I don't have fractions, which will be a little easier. Okay, so z came from the little triangle. So which side over here comes from the little triangle? Holy hot dog, you guys, it is the 10. So it'd be 10 over, now 23 is the whole side of the big triangle. How do we find the whole side of this big triangle? Well, this side is broken down into 10 and 6. So how do I find the entire length if one part is 10 and one part is 6? Man, you guys are so smart. I do have to add these two together. So to get the length of this entire side, which I know it's going to be a little crazy with all this stuff going on, I'm going to add 10 plus 6. Okay, so that whole side is 10 plus 6, which is 16. Okay, so I have the little side to the whole big side. Okay, 10 plus 6 is 16, which I know that's a lot going on. If that's confusing you, don't write that on your paper, okay? But that's where that 16 is coming from. Okay, and again, before I start my cross multiplying, I want to try to reduce down any fractions if possible. Okay, which I see that I can reduce down 10 over 16. Do you guys know a number that will divide into 10 and 16? Of course you do, because you always do. Okay, a number that will divide into 10 and 16 is 2. So I'm going to reduce this down real quickly. 10 divided by 2 is 5, and 16 divided by 2 is 8. Okay, so I'm actually going to be using, okay, this is the one that reduced down. I'm actually going to be using 5 over 8 in my new proportion. Okay, so I'm going to have z over 23 equals 5 over 8. Okay, and from here we just cross multiply. So let's go. It's like a cross multiplying party. Those are some good parties right there. Cross multiplying, man. Okay, so z times 8 is 8z. And that will equals 23 times 5, which I'm pretty sure is 115. I'll double check though. It's never wrong to check yourself. So 23 times 5. Yep, 115. Look at that. Okay, so 115. And then from here, I just solve for z, which the 8 and the z are secretly multiplying. So the way that I bring 8 to the other side is by dividing both sides by 8. Okay, which 8 divided by 8 will cancel and turn to 1. 115 divided by 8, well, this won't reduce down any further. So guess what, you guys? Z is just going to be 115 over 8. And guess what? That problem is donezo.